So modes of addressing. Modes of addressing means while you are programming assembly language, you are writing assembly language program, or you are writing low level language programs, how we can access the computer's memory. What is computer's memory? RAM. I told you that whenever we talk about memory, we are talking actually about the RAM, RAM, random access memory. And whenever we are talking about storage, we are talking about those memories which can hold data even when the computer is switched off. All right, so memory means RAM. So mostly we are not concerned about storage in this particular topic, processor fundamentals. All we are concerned is with RAM. So this is actually a way to access computers memory, and there are certain modes. So there are different commands, there are different low level commands. So we need to use these commands to access data from the memory. Remember, you have to think this way, that there is a command which is being executed in the microprocessor. That command, while being executed, requires some data from the memory. So what are the ways, what are the modes we can use to access that data from computer's memory while the command is being executed? So the first one is direct. Direct addressing. All right, so direct addressing, basically what happens, let's say you have got this memory. There are three memory addresses: 50, 51, and 52. At 50 we have got 8, at 51 we have got 9, and 52 we have got 15. So this is actually address. This is actually data placed at that address. There is no instruction, just the data. So direct addressing mode requires you to write a command which is called LDD. What do we call that command? LDD. LDD. LDD means load direct. Load direct from the given address. And the example of this is actually LDD 51. So this command has got two parts. First one is LDD, and the second one is the address. All right. So LDD says load direct from the address 51. Okay, load direct from the address 51. So this 51 is actually the address of memory. So what will happen? Let's say I've got accumulator. This is accumulator. What do I get in accumulator when executing this LDD 51? I will have 9 in the accumulator. So this is very simple, that this command which says LDD 51 means load direct from the address 51, and whatever in the address 51 at the address 51 will be loaded to the accumulator. All right. So this is the first command. Second one is indirect. Indirect addressing. Indirect addressing is a different command. It is LDI. LDI means load indirect. Load indirect. All right. So basically, let's say again, I've got this memory. And there are addresses in this memory, let's say 65, 66, and 67. At address 65, I have got 67 placed. Then I have got 8. Then I have got, let's say 3. Indirect means that the data which is required is not actually at the given address. The data which is required is not actually at the given address, but the address of the data is placed in the given address. Let's say I execute this command LDI 65. System will go to 65. At 65, it will see that the address is 67. The data is 67, but this is not the data which is required. This is indirect. So system will now go to this particular address 67 and find the data. So what is the difference between the direct and indirect? Direct, whatever the address that is there, the data is present at that address. So if it is LDD 51, go to 51, take the data, place it in accumulator. Whereas in indirect addressing mode, what happens that the address that is given in the command is actually not the data's address, but it is actually the address of data. This just goes one time. This doesn't go on and on and on. This is just one time. So at 65, we will find the actual address of the data. So we will see 67, then we will go to 67. And in accumulator, we will have 3. So get the idea? This LDI is basically indirect. So whatever the address that is pointed is actually the address of the data. So at 65, this is 67. So we go at 67 and then the data is found and that data is brought to accumulator. Remember, whenever the data is fetched from the memory, it is always placed in the accumulator. Now, you might say that, sir, what is the need for having this indirect address when we can directly write 67 and we can fetch 3 like in LDD. So there is a reason behind it. So basically what happens, let's say last time when we were discussing the bus width, I told you that bus width is a factor which actually impacts the performance of the system, because if we like to use more memory, we have to have enough number of wires in the bus to access that memory. Let's say the bus width is 3. Word size or the bus width of a particular computer is actually 3. Bus width or the word size. What is the word size? The number of wires in a bus. Okay? Which bus? The data bus and address bus. So how many addresses this computer can access? That is 2 to power 3. It can access 8 addresses from address number 0 to address number 7. All right. So if we have got bus width 32, it means that we can access as many as 2 to power 32, which is actually 4 GB. 4 gigabyte of RAM. All right, so from 0 to 4 GB. So what is the word size? The amount of data a computer can process, produces, consumes, the amount of memory a processor can access. All right. So now what basically happens, let's say we have got bus width of 32. So it means when we write a single statement of assembly language, a single instruction of the assembly language, that instruction is in binary form. All right, everything in low level language. I told you that assembly language is actually the low level language. Whatever that you write is basically with the help of assembler converted to its binary form. So basically, let's say if I write a command LDI65, LDI65, this LDI is basically called opcode, operation code. And this 65 is actually called operand. All right, what do we call this 65? Operand. Now basically what happens, let's say हम example ले रहे हैं 32-bit के system की. All right, so in 32-bit के systems में क्या होता है? In 32-bit के systems में जो आपके पास एक word होता है, एक command होती है, एक instruction होती है, that instruction is divided into 2 parts. Those 2 parts are what? Opcode and operand. In this LDD 51, this is LDD, which is opcode, and 51, it is operand. In this LDI 65, this LDI is opcode and this 65 is operand. Similarly, over here in this bus width, in this word size, we have got a 32-bit system word size. Okay? अच्छा, अब इसमें क्या होता है कि out of these 32, system allocates 20 bits for the opcode and 12 bits for the operand. All right, so $20 bits for the opcode and 12 bits for the operand. This is a ratio of 5 to 3. A ratio of 5 to 3. Okay, this is a ratio of 5 to 3. Now, basically, that means that the maximum address a single instruction can access is basically maximum address that a single instruction can now access is 2 to power 12. All right, so 2 to power 12 is basically 4K. 2 to power 12 is 4096 or 4K memory. All right. And with the bus width of 32, the maximum memory that you can access is this 4 GB. Maximum memory that you can access is 4 GB. But with the command, since operand is only holding 12 bits, you cannot go beyond 4K. So there comes the help from LDI. ठीक है, इसको आप समझने की कोशिश करें. बेसिकली क्या हुआ कि एक कंप्यूटर का वर्ड साइज है 32 बिट्स. You might have heard of this thing कि हमारे पास 32 बिट्स का सिस्टम है, हमारे पास 64 बिट्स का सिस्टम. तो बेसिकली ये जो 32 और 64 होता है, इसका मतलब ये है कि सिस्टम में जो बसेस चल रहे हैं वो 32 बिट्स के हैं या 64 बिट्स के हैं. सिस्टम के अंदर जो इंस्ट्रक्शंस आ रही हैं डेटा बस पे वो 32 बिट्स की हैं या 64 बिट्स की हैं. मेमोरी में एक एड्रेस पे जो डेटा रखा हुआ है वो 32 बिट्स का है या 64 बिट्स का है, या प्रोसेसर में एक वक्त में जो डेटा कैच हो सकता है वो 32 बिट्स का है या 64 बिट्स का है. So let's say if it is one instruction, we know that at one particular location in the memory, either we have one instruction or the data. So one location of the memory is, let's say, of 32 bits. And if it is data, complete 32 bits are accessible. But if it is one instruction, then that instruction is divided into two parts, the opcode and the operand. This opcode is also known as mnemonic. These are the commands of assembly language. M-N-E-M-O-N-I-C. This M is silent, mnemonic. All right. And this operand is also called address part. What do we call it? Address part. ADDRESSPART. Address part. So mnemonic and address part. There are two types of instructions. If you look at them apparently, either they are just the opcodes and there is no operand, or they are having both opcode and operand. In any of the cases, every instruction is divided into two parts, opcode and operand. Operand is address part. So the maximum address that you can access is basically 12 bits. So first 20 bits will be taken by the command itself, the mnemonic or the opcode, and later 12 bits are for the address part. So let's say the maximum address that you can access is 2 to power 12. अगर हम इसको depict करें तो let's say देखें हमारे पास ये हमारी main memory है. Indirect addressing. Let's say हमारे पास ये main memory है. और ये जो main memory है the size of this memory is actually 4 GB. All right. So the maximum size of this memory is 4 GB. Okay. I want the data from one of the address which is actually somewhere here. Okay, somewhere here. अब इसका लेट से हम एड्रेस ले लेते हैं, लेट से हम ले लेते हैं 3.2 GB है ये. इसका हम एड्रेस ले लेते हैं 3.2 GB पे हमें डाटा चाहिए. डाटा यहाँ पे रखा हुआ है लेट से 8. हमें ये डाटा चाहिए. हमारे पास 32 बिट्स का सिस्टम है. जो हमने कमांड लिखी वो हमने लिखी LD. अब हम LDD करते हैं तो देखें हमने अगर 3.2 GB लिखना है तो 3.2 GB के लिए हमारे पास 12 बिट्स काफ़ी नहीं है. हमें 3.2 GB के लिए हमारे पास बहुत ज़्यादा बिट्स होने चाहिए which are at least let's say 25 बिट्स. तो हमारे पास कितने बिट्स हैं? सिर्फ 12 बिट्स हैं. तो हम क्या करते हैं, हम लिखते हैं LDI. अच्छा, LDI लिखने के बाद आपको जैसा कि मैंने बताया कि यहाँ पर ऑपकोड में आपने ऑपकोड के अंदर 20 बिट्स ले लिए. तो LDI जो है वो आपके पास आ गया यहाँ पर LDI. आपके पास सॉरी ठीक है, आपके पास यहाँ पर आ गया LDI. और अब आपके पास कितने बिट्स बचे LDI के बाद? होल्ड ऑन, लेट मी क्लीन दिस अप. ठीक है, LDI। और अब हमारे पास बचे 12 बिट्स। अब 12 बिट्स के अंदर हम मैक्सिमम एड्रेस जो है वो ले सकते हैं 4096। तो हमारे पास ये आ गया 4096। 4K एड्रेस हमें एक्सेस करना है ये, और हम सिर्फ एक्सेस कर सकते हैं यहाँ तक, 4K तक। तो बेसिकली क्या होता है कि हमारे पास जो 4K एड्रेसेस हैं, हम उसमें से किसी एक एड्रेस में एक्चुअल एड्रेस का एड्रेस सेव कर देते हैं। 4K के अंदर हम किसी एक्चुअल एड्रेस का एड्रेस सेव कर देते हैं। फॉर एग्जांपल ये हमारे पास 4K एड्रेसेस हैं। ओके, 4K एड्रेसेस हैं, हम इनको डायरेक्ट एक्सेस कर सकते हैं, लेकिन हम इस 3.2 GB के एड्रेस को एक्सेस नहीं कर सकते। तो हम क्या करेंगे, लेट्स से हमारे पास ये एक एड्रेस है 50, ये है 49, ये है 51, और ये चलते चलते हमारे पास 4096 तक एड्रेसेस हैं। तो लेट्स से हमने 51 के ऊपर 51 के ऊपर यहाँ पे 3.2 GB रख दिया, क्योंकि 3.2 GB हम यहाँ पर आसानी से इसलिए रख सकते हैं कि हमारे पास पूरे 32 बिट्स अवेलेबल है। हमने यहाँ पे 3.2 GB रख दिया। हमने कैसे रख दिया 3.2 GB? क्योंकि हमारे पास पूरे 32 बिट्स अवेलेबल है, क्योंकि उसमें डाटा है। जब हम इन 32 बिट्स को किसी कमांड के लिए इस्तेमाल करते हैं तो बेसिकली वी हैव टू डिवाइड इट इनटू 20 and 12, but if it is just the data, we can use it for the data, all 32 bits. अब 32 bits को हमने इस्तेमाल किया और 32 बिट्स के अंदर हमने जो एक्चुअल एड्रेस है वो सेव कर दिया। तो अब हम यहाँ पे लिखेंगे LDI 51। तो अब सिस्टम जो होगा वो LDI 51 से बेसिकली जाएगा 51 पे। 51 से देखेगा कि यहाँ पर हमारे पास 3.2 GB का एड्रेस रखा हुआ है। वो 3.2 GB से जाएगा उस एड्रेस पे, और जो उस एड्रेस पे डेटा रखा हुआ है वो एक्यूमुलेटर में लेकर आ जाएगा। ऑलराइट, so this is very simple. When we write a command, actually that command requires us to bifurcate the available number of bits. That bifurcation is between the opcode and the operand. The address actually goes in operand. The division is with respect to 5:3 ratio. So 5 goes for operand and 3 goes for opcode. So less number of bits opcode would not allow you to access complete memory locations, all of them, because all of them require lots of bits which are more than 12 bits. So in that case, what basically happens that we point to one of the address which we can access directly, and at that address we place the address of actual data. LDI goes to that address, finds the address of actual data, reaches out to that particular address and brings in the data. So that is why we use LDI, indirect access. Okay, now we have got number 3, immediate access. Immediate addressing. Immediate addressing means that we don't have any address, rather we have got the data. Just take that data. It's like a variable is given a value, a constant value. So basically the command is LDM. LDM means load immediate. Load immediate. Immediate means there is no address of the memory. All you have to do is to take this address and put it in the accumulator. So let's say I write a command LDM, let's say 7. Now to differentiate the constant from the address, देखिए अगर आप सिर्फ 7 लिखेंगे तो सिस्टम लेगा कि ये जो है वो एड्रेस है, तो हम यहाँ पे आगे क्या लिखते हैं, हैश साइन. हैश साइन का मतलब है कि दिस इज द वैल्यू इटसेल्फ, दिस इज नो एड्रेस, दिस इज द वैल्यू इटसेल्फ. सो बेसिकली आपके पास एक्यूमुलेटर के अंदर एक मिनट बेटा, मैं आपका क्वेश्चन ले रहा हूँ. आपके पास 7 आ जाएगा. क्वेश्चन ये है, सो द मोड्स ऑफ एड्रेसिंग आर बेसिकली हाउ एनी कंप्यूटर आर्किटेक्चर स्पेसिफाइज द एड्रेस डेटा दैट दे वांट टू एड्रेस टू. यस, exactly. Basically this is a way of accessing addresses using assembly language. All right. Now this was immediate addressing. Sometimes we don't want to access data from the memory, rather we like system to store the value that we are actually giving it. जैसे हम कहते हैं ना x is equal to 5, यानी कि x के अंदर 5 रख दो. नहीं तो हम कह सकते हैं कि x is equal to y, मीन्स के y पे जाओ, y का डाटा लेके x में रख दो, या इनपुट x कि सिस्टम इनपुट ले फिर x में रखे. तो हम क्या करते हैं, हम सिंपली ये कहते हैं कि आप जो है ना वो ये वैल्यू है, बस इसको x में रख. तो हम क्या करेंगे, लोड इमीडिएट, बट टू डिफरेंशिएट फ्रॉम the address we have to put hash sign. Then we have got indexed addressing. Indexed addressing is used the way we use loops. If we like to access consecutive memory locations in one go, and we want to, let's say, have an operation of additions from address 50 to 59, we want to take data from every single address and we want to add it. So we can run a loop using indexed addressing. Okay, now index addressing is actually written as, the opcode for index addressing is LDX. LDX. It uses index register. It uses index register. Index register or IX. The name of index register, we abbreviate it like IX. Okay, IX. So it uses index register. So basically what happens, let's say we have got this command LDX. First of all, let's say we have got this index register. we have got this index register. Index register has got 4 in it. 4. All right. So I write a command ldx. So this is actually load indexed. All right. So let's say I write a command ldx 50. All right. So this 50 is called base address. Base address means where the whole thing will start. And this base address will be added to the content of the index register. The content of the index register is called offset. What do we call it? Offset. Offset. ठीक हो गया? जो result आएगा, this would be the actual address, final address, which is 54. Okay, so what basically happens when we write this command load index ldx, we give a base address and system keeps changing the content of index register. That content of the index register is added to the base address to find the final address to access the memory. All right, so let's say I've got this memory. This is my main memory. All right, so this is my RAM. So this is address 50, 51, 52, 53, 54, and 55. Okay, and I have got these values placed in it. 7, 8, 9, 10, 11, and 12. This is the data at these addresses. Let's say index register is 3 and I pass this statement or the instruction ldx 50. So what accumulator would have? अब देखें आपने क्या लिखा है ldx 50. 50 plus 3 becomes 53. Okay, so 50 plus 3 becomes what? 53. So system will access data from address 53. So index register is 3. We have passed this command ldx 50. 50 plus 3 becomes 53. System will access data from 53 and that data will arrive in accumulator and that will be 10. So let's revise. Modes of addressing. मोड्स ऑफ एड्रेसिंग का क्या मतलब है बेटे? मोड्स ऑफ एड्रेसिंग का मतलब है कि हम कितने तरीकों से डेटा को असेंबली लैंग्वेज लिखते हुए एक्सेस कर सकते हैं. These are actually in the form of instructions, assembly language instructions or low level instructions. There are certain modes of addressing. First one is direct. Direct addressing means whatever the address that is given, go to that address and bring in the data. And whenever the data is fetched, it is brought in the microprocessor from the memory, it always reaches out to accumulator. It is always stored in accumulator. So direct addressing, LDD, load direct. So if I write load direct 51, so system will go to address 51 and bring in the content which is actually 9, and that content will go to what? Accumulator. So LDD 51 goes to, system goes to address 51, 9 and brings in 9. All right. Then system has another command called indirect addressing. Sometimes it becomes difficult that we access to an address because that address is out of the range. Why it is out of the range? Because when we write a command, the number of bits which are available are not actually completely available for the addressing. Address cannot be written in complete number of bits. Let's say अगर हमारा system 32 bits का है, तो system क्या करता है? उन 32 bits को जो है वो convert करता है command के लिए, instruction के लिए और address के लिए. जो इनकी division है वो होती है, रेशियो होता है उसका 5:3. तो 32 बिट के सिस्टम्स में ये होता है 20 and 12. 64 बिट्स के सिस्टम में ये होगा 40 and 24, whatever. So what is bus width? Bus width or the word size is actually the number of wires available in address bus, number of wires available in data bus, and the amount of bits that we can hold in the register. Obviously जो data बस पे डाटा आएगा वही आप एड्रेस उसके अंदर जो आपका मेमोरी डाटा रजिस्टर होगा उसमें आप रखेंगे. तो आपके पास जो रजिस्टर है उसके अंदर आपके पास लेट्स से अगर 32 बिट का सिस्टम है तो 20 बिट्स जो है वो आप कोड के लिए हैं और बाकी जो 12 बिट्स हैं वो ऑपरेंड के लिए. अब आप जो मैक्सिमम एड्रेस एक्सेस कर सकते हैं वो 12 बिट्स का ही कर सकते हैं. 12 बिट्स से आप ज़्यादा का नहीं कर सकते. But what if your data is placed somewhere beyond 12 bits? What we do कि इन्हीं 12 bits के बीच में जो हमारे पास available addresses होते हैं, जो हमारे पास available addresses होते हैं, हम उन्हीं address में उन्हीं जगहों पे कहीं पर actual data जो है वो access करने के लिए उसका address place कर देते हैं. तो let's say मैंने आपको ये example एक बताई कि हमारे पास ये मेन मेमोरी है, दिस इज ऑफ 4 GB. We have data at somewhere 3.2 GB, but we cannot access this 3.2 GB directly because we can access only 2 to power 12 4096 addresses directly. So what we do, हम 4096 जो है इनमें से किसी एक एड्रेस के ऊपर 3.2 GB का एड्रेस रख देंगे और हम उसको एक्सेस करेंगे LDI 51. Since we are having the data there only, no instruction, we are having all 32 bits available. So in 32 bits के अंदर हम 3.2 का एड्रेस आराम से रख सकते हैं. तो सिस्टम जाएगा यहाँ पर 51 पे, यहाँ से एक्चुअल एड्रेस लेगा, एड्रेस पे जाके हमें डाटा ला कर दे देगा. अच्छा, इसके लिए मैंने आपको ये बात बताई थी, इनडायरेक्ट में आपके पास जो प्रोग्राम्स आएंगे वो तो छोटे छोटे से प्रोग्राम्स होंगे, उसके अंदर ये होगा जैसे आप देखें आपने यहाँ पे इनडायरेक्ट है, तो उसमें simply what you have to do is you have to see if it is indirect, it means that you are not going to access the data directly, rather you would have to actually go to this address, find what is saved at that address. This is what is saved is not the data, rather it is the address of the data. Then you will go to that address and bring in the data. This is simple. Technically, question may come that why do we use indirect addressing? In that case, you would have to describe it. Otherwise, if it is for trace, it would be very simple. That whatever the address that is given with indirect, you will have to go to that address, find what is at that particular address saved. So you will pick that up, go to that address and bring in the data. Okay, so indirect actually makes you access the complete memory. Then we have got immediate addressing. Immediate addressing. In immediate addressing, we don't have any address. Rather, in operand part, we place the value itself. And how do we differentiate a value from the address? By putting hash in front of it. So if you have got a value that you want to save at a particular, that you want to save in accumulator, all you have to do is to write that value and put a hash sign there. But the command is LDM. LDM means load immediate. So LDM, load immediate. LDM 7 means load 7 to the accumulator. That is very simple. There is no address, memory address involved. And then we have got indexed addressing. It uses indexed register. The role of indexed register is to help the system to access memory addresses in a loop, in a series, without writing so many commands. All right. So what basically happens when we write LDX means we are going to use index register. The abbreviation of index register is IX. So let's say we write command LDX 50. That means that this 50 is a base address. That 50 will be added to the content of index register, which is called offset. So 50 plus 4 becomes 54, and that is the final address. So let's say I've got this memory which has got addresses 50, 51, 52, 53, 54, 55. All right, so 54 and 55. So basically, what will happen? Let's say I have written this command LDX 50 and the content of index register is 3. So 50 plus 3 becomes 53. So system will go to 53 and bring in 10 to the accumulator. So that's about it. There are one or two more addressing techniques, but you have to first understand all these basic 4 addressing techniques. 2 more, relative and other, we will discuss about it. तो यहाँ पर हमें बेटे ये पता चला कि जब हम ट्रेसिंग कर रहे होंगे प्रोग्राम्स की, तो हमें देखना होगा कि डाटा कैसे पिक किया गया है, डायरेक्ट पिक किया गया है, इनडायरेक्ट पिक किया गया है, इंडेक्स करके पिक किया गया है, या डाटा मेमोरी से पिक ही नहीं किया गया, रादर एक वैल्यू दी गई है जिसको हम इमीडिएट कहते हैं और उसको एक्यूमुलेटर में सेव किया गया है. तो ये है. अच्छा, अब कोई क्वेश्चन हो तो प्लीज मुझे बताइए.